recording now. Any second. All right. Looks like it's recording.
Yeah, it's showing for me too.
Cool. So as far as features go, did you find anything that you thought might be valuable for a way to test it?
I thought, well, the polar coordinate thing, I mean, I had never even thought about it like that, but I thought that would be useful as far as like training like you said, training the machine learning. So like it has a starting point.
Mm-hmm.
So obviously that's not going to be the most ideal solution, but it's going to be a lot better than starting where the original MATLAB file starts from.
Right.
So yeah, I think the polar coordinates are going to be really useful for figuring out at least the starting location for the algorithm.
Yeah, I was trying to kind of think about it along those lines, like try to think of the patterns involved with the polar coordinates. So, because I was looking at things like with linear algebra, like trying to see if like we even went to like eigenvalue, eigenvector stuff to see if like that might work. And I was like, well, it's not necessarily related here. And I was like, well, what about the golden ratio? Does that work? And I was like, the thing with it is the golden ratio involves a line. And I realized with this, like with the polar coordinates example, we want to be able to have an input of a single coordinate rather than how it might relate to other coordinates and have that map out to a sequence independent of the other coordinates. So one thing, and this is definitely not going to produce an optimal route, but I thought, you know how he sorted by like theta largest to smallest. What if we did that just with the x or the y? Like started, say, when x equals 0, and then just kind of went up or down to the next point, kind of almost drawing a very crude, what's the word? I'm blanking on it, but a very crude polynomial, a very kind of, and then, once it reached the last one, it would just draw a straight line back to the original point, wherever the starting point was. So like that's definitely going to be suboptimal, but it's one way to not have, I mean, you'd have like one line crossed, but that's about it. And I mean, it's one way to get a starting point without a ton of things crossing over each other. And you could do it in the same way from the x as well, but that would, well, it would produce a graph going up rather than a graph going to the side. But either way, that defines your starting point by like sorting by x or sorting by y. And we could try either one, see which works better. I guess if you found which one had a greater like absolute value or a greater distance between the first and the last, like if you sort by y and the range between, hold on, let me make sure I'm getting this right. If you start at x equals 0 and you sort by x, but the range of range of x is greater than if you start at y equals 0 and sort by y. So whichever one has the smaller distance, you'd want to sort by that, I think.
Yeah.
Or smaller range. So you can sort, you can find, or I guess we would do that. That would be pre-data processing. And so for a given set of coordinates, if the x range was larger, then we would sort by y instead. And if the y range was larger, we'd sort by x. And then just have it start from 0 and go up or go sideways, or to the right, I should say. I guess the thing would be is if there's ever anything on a negative axis, but if it's sorted, then it just starts at the lowest and goes up, or either way.
Yeah. Also, a similar idea. I think that would work, but even with the the polar coordinates, we could do like a range of like 5 or whatever row values, so that it would go around in a circle in a certain range and then start with the next inner circle. Similar idea to what you had, but still using the polar coordinates. I don't know if that would give us really any different answers. But I don't know, I just thought, and like you couldn't do just like one specific row, because then you just have a billion circles on there. So if you did it in like a range, it could go in a certain ring and then the next inner ring and then next inner ring. And it would just go around in a spiral to the inside or to zero.
Yeah, that's interesting. So sort of like like you said, a spiral, a swirl, almost like a snail shell pattern.
Yeah.
Yeah, I like that idea. I think it would be interesting. So because that takes, because the simply doing theta ignores whatever the row value is. But if you start in the center and determine where there is, like if you sort by theta first and then sort internally by row, I mean, I wonder how you would do that. Like, because like you'd want the smallest row for a given range of theta. So I guess your thetas, you would probably do a gradient. So you wouldn't use a theta value per se. You would just, or I don't know. I'm trying to think of how to do that. I guess you would sort by the rows. Yeah, I guess that would be sorting by row, because you'd start in the inner where it's smallest and go around and around and around over and over again until you reach the outer one. Yeah.
And yeah, I was saying like do, so you couldn't do row equals 1, row equals 2, row equals 3. It would be like a range of within a range, so that you would, like, it would be almost like a jagged circle and then go out to the next ring past that. Because like I said, it most likely with 100 points, you'd end up with 100 circles as opposed to 20 circles or whatever, where it'd be a lot more if you went each specific value had its own circle. Do you know what I'm saying?
No, I'm not following.
So like, it's like if you picture the circle, the polar coordinate graph, you would need to like, and how there's quadrants for the degrees, you would need like rings going outward from the center, and then within, if you did like 3 rings, within those 3 rings you would go around based on the theta, and then out to the next ring and around to draw a circle connecting all the points within the rings, so that there'd be like 3 rings, and the 100 points would be spread out between the 3 rings, and then you would just connect all the points in one ring and then go out to the next one and then the next one after that. So kind of like a snail. So yeah, it would be like a snail pattern, but then within each snail ring, there'd be the dots that you're connecting, and then you go out to the next one.
I think I see what you're saying. The only problem I see with that is that it ignores the distance that would be required to jump from one ring to another. And that is a factor in the TSP, because with TSP, you have to connect all of the points. And so I think we need a pattern that's going to, like we can mentally divide it but with the algorithm itself, we can't necessarily define and create separate systems of routes, if that makes sense.
Yeah, that does.
So I get what you're saying, and it would kind of like, it would start on the innermost, and it would get, like, it would almost be a full circle though, but it would have to jump to the outer ring and not complete the circle until the very end.
Yeah. I'm sure that wouldn't actually be better than how you were doing it with the regular Cartesian coordinates. I just thought of that, and I didn't know if it would actually be any better or not.
Well, it's all something to try at this point. Honestly, it sounds like it would probably be better than using the Cartesian coordinates, because it seems to me to mimic more like that pattern found in nature with the spiral pattern. So it'd be interesting to see how well that really works, and whether it whether it actually would end up sort of following the golden ratio. But I think we have a good start to this, and we can do more research as the course goes on.
Mm-hmm.
Any other thoughts?
No, other than just figuring out the just ideas. Like you said, with the Cartesian or the polar, I don't really have any other like ideas right now on how we would get a starting sequence that we could figure out.
Okay. Well, sounds good. So, so you'll do the documentation in Excel and discuss kind of what we've discussed here, right?
Mm-hmm. Yeah, I guess I'll make like an Excel thing that I have an idea of what he wants, and then show him tomorrow and see if that's what he wants or exactly what he's looking for. But yeah, I'll do the Excel. Let me read what he says. Use of Excel to show features and targets. So the target is the sequence of points as opposed to like the absolute distance right now.
Yeah, it's a sequence.
Mm-hmm.
Cool. And then I'll do the MATLAB part, explaining that video, and I'll send that to you.
Okay.
Do you mind putting the video together?
Yeah, I can do that.
Okay. Sounds great. Well, thanks, Keith.
Yep. See you tomorrow.
See you then. In the second assignment for Engi 420, Keith, Harvey, and I will be examining the TSP problem and beginning some analysis on how we might use machine learning to help solve it to create what's called a warm start for the genetic algorithm. In other words, can we use machine learning to produce a suboptimal solution to the TSP problem so that the genetic algorithm doesn't have to run through as many iterations? In this particular segment of the video, I'm going to be overviewing the MATLAB TSP file that we've been given and how it generates a solution to the TSP problem using 100 stops. Keith Harvey will overview the Excel, and we'll also include a snippet of our discussion talking about the potential features that might be useful for the machine learning algorithm. Here in MATLAB, I have the TSP genetic algorithm file pulled up. We have a lot of comments exploring the summary of this particular file, so I'll just go over the key points. Obviously, we have a traveling salesman problem, and there are a few notes as to how this may be used. Since the TSP genetic algorithm here is listed as a function, it has some default configurations that can be reconfigured using this getConfig function. And as the comments point out, we can pass in some user-defined coordinate points. For example, using the user config, we can pass in a struct containing some random xy coordinates, or we can pass in what the author considers to be more interesting xy coordinates, where we are a little bit more involved into what exactly those coordinates are. The algorithm can also handle 3D xyz coordinates as well. And we can set some other defaults, such as the population size and the number of iterations. So there are a number of things that we can use, but there's a default configuration here that shows 100 random cities. So I'll go ahead and run, and you can see the genetic algorithm solving for the best route. There's a lot of crossover, but as you can see, it becomes a lot more there are a lot fewer crossovers as the algorithm solves for the best route. What we want is to provide something that's a lot better than the initial random starting route and gets the algorithm, or so that the algorithm starts off with something a lot closer to this optimal route and it doesn't have to run through as many iterations. So here we have the final map of all the city locations, total distance, how well our algorithm performed. You can see it still has to run through a lot of iterations before it finally converges. So we want to reduce this number of iterations. And then there's the distance matrix as well.
So for the MATLAB part of the first homework, we have the traveling salesman problem that Professor Rich showed us in class. I changed it to 10 iterations. 10 points, and then to get all of the data all at once, I have a for loop for 10 iterations. So I have my 0 matrices up here, and then as it runs through doing the traveling salesman problem, it translates the XY coordinates also into polar coordinates, which I will show in a second. And then through here, it's just populating the matrices with all of the data. And then at the end here is the graph function. So I will run it. And here you can see the XY coordinates on a graph and the polar coordinates that it generated here. And just for an example, I'll show you the IDX, which is the sequence. So 4175 for the first one, next generated is 487, and so on and so forth for each one. And then over here in Excel, I have it set up so the features are shown same way it was set up in MATLAB, where all of the x coordinates of the first one, the second one, the third one, the y coordinates, the rows, and the thetas are all listed in order based on the record and which point they are in the record. And then they're all targets for record 1 is different stops, record 2, 3, and have all 10 stops here. And these numbers are different because this was from a previous random generation.